Alright then guys, today we're going to be doing a new Pwnable.kr challenge, and the challenge that we're going to be doing today is going to be called lotto, which is a 2 point challenge made by Pwnable.kr. So let's get started. So one of the very first things I did was just run the program to see what it does. So I just ran lotto and see what it does. We get a menu, we get 1, 2, 3. I picked 3, it exits out. 2 prints out the rules, and then it prints it out again. So I'm gonna play 1. Play a game. We enter 6 bytes. I guess we can enter whatever bytes. That's what I'm assuming. So I do 1, 2, 3, 4, 5, 6, and then I guess that wasn't the answer. So I'm guessing we had to find a way to guess the 6 bytes. That's what I'm thinking initially at the first time, but we could go look at the code and see what's actually going on. So if we do something like cat lotto.c, we see the source code that was given to us. So if we look closely at the source code, we have 3 options, like I said: play, help, and then exit, which just prints f by, and then we exit out the program. Help just prints out the rules, which is basically what I said before. And I guess the whole logic comes inside play. So play, we submit 6 bytes. It reads in 6 bytes, which is good. Printf lotto started. That's where it prints out with a new line. And after that, it opens up the u random, and I guess it fills it up. It fills up this u random with 6 random bytes. That's what I'm guessing what's happening. And for the most part, it fills it up with bytes of just random, I guess for the most part, between 45. So that's basically what's going on. It fills it up with random values of 45. And with these random values of 45, these values specifically, these values are basically 45 ASCII values between 1 and 45. So if we go back to ASCII table, it's going to be from values 1, which is the representation of a char, since it's getting filled up inside a char. We can see it right here in char. So right here it could go from 1 to 45. So it'll be start of heading all the way, all of this to 45, which is this minus sign. So it could be a minus, a plus, star, parentheses, ampersand, all not ampersand, but you get what I'm trying to say. Starts from 45, all of this and all of this. So all the red, so 45 minus sign, all of these characters to this. So anyway, it fills it up with 45 random characters for the most part. And then this is where we calculate the lotto score. So this, if you guys don't know about for loops, this is where the main issue comes into play. And I'll show it to you guys what's going on. So we have 2 for loops. Like I said, for loop right here going through 1 to 6, for loop right here going through 1 to 6. I have a for loop right here representing, and then at the initially I is equal to 0. So that's basically what's happening. I is equal to 0. And then we have the second for loop, which is j equal to 0. And we have j equals to 0 right here. And then right here we have the if statement right under the second for loop. So that's what I have here. So what's happening initially is that at the beginning, so lotto, like I said before, is filled randomly with random bytes. So lotto, for the most part, I think I could write right here. So lotto is just random characters up between 1 through 45. So these 1 through 45 characters could probably be this, hashtag, $, 1, 2, 3, 4, and then I guess 2 parentheses. That's basically 6 now. 1, 2, 3, 4, 5, 6. That's 6. And then we could submit whatever we want. So I just want to submit, let's see if I want to submit just all exclamation marks. And I'll show you why this works for the most part. So you would think that we had to guess all these 6 lottos. That's what this programmer is thinking. This programmer is thinking that basically what we're doing is we're basically checking everything from lotto and everything submit are equal, and this bypasses is equal to that, and wants to tell you how in this for loop. So with this for loop, how for loops works in general, it initially starts at I equals to 0. That's what happens at the beginning. But next we enter the second for loop with j equals to 0. And then so 0, 0. So that's gonna match. So for sure this matches. So we have one match. But then later on, I guess what the programmer thought is that I is gonna increment, but I never increments in this case. Only j increments because we're still inside the second for loop. So J will always keep on incrementing to 1, 2, 3. I guess I could keep on writing right here. 4, 5. And the reason why it's 5 is because it says J has to be less than 6, so 5 is less than 6. Other than that, it's not gonna go through. Basically, that's it. So what's technically happens is that I never gets moved. I never gets shifted at all, or I never moves. It only moves once we're done going through the entirety of J, and once we're going through the entirety of J, that's when I becomes, it shifts to 1. And like I'll just copy this, so then I becomes this values. But basically what happens, it becomes 1, 1, 1, 1, 1, 1, and 1 throughout the entire thing. So same thing right here. So that's basically what's happening. And I guess this is where, oh wait, I just put 0 right here. So this is basically what the programmer thinks is, what the programmer thinks that's going on is basically is going 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. It's checking every one of them at a place, but it's not. What it's basically doing is just checking. Well, in my case, I have it 1, but I would just do 0, 1, 2, 3, 4, 5. Well, this is what the programmer thinks it's doing. It's checking all the values it's checking values if they're equal at the same place, but that's not the case. It's just checking it for lotto, which is the randomly generated one. It's only checking the first value. So technically, we could technically brute force this since it's only 45 characters. So what we could technically do is just write a script that just brute forces this. It keeps sending the exact same. Let's say we submit only exclamation marks. Eventually, the very beginning character is going to be an exclamation mark, because it just gets randomly generated for the most part. And that's basically what's going on with this. So if we go back, I wrote a script that took me a while to debug because I didn't know what was going on, but eventually I got it. So if we go to nano, because I wrote in the temporary directory right here. So if we go to nano, we started a Pwn Tools from Pwn Tools import all. This is how I do it. Everyone has their own special ways. This starts up the process for the most part, and then this receive line, this receives the menu option. This so we get the entire menu right here, and then after the menu option, after we receive it, we want to be able to send in the value that we want to go to. So in our case, we want to send in 1. And then after that, we receive it again, and this time we receive like the option asking us to enter 6 bytes. And then after that, we send in our 6 bytes. And then we receive 2 separate lines. So I'll explain what this second line is. So this one is telling us bad luck. And then this one's telling us, I think, re-enter, but I could be wrong. We could show it again. So I'll show you guys by running the code again. So we'll do, what is it called? Lotto. So we enter 1, and then we enter 6 bytes. Let's say, or exclamation mark, 1, 2, 3, 4, 5, 6. And then it's gonna, oh wait. That's funny. I guess we got it initially, our first try, because it's random. And I guess out of luck, we managed to get this, but I'll show it again. So 1, 2, 3, 4, 5, 6. But you saw how it worked. So you saw how it works. It's like, since they only compared. So I'm guessing on their end, it was probably something similar to this, where it was just randomly generated, but the very first line was exclamation mark, and what we submitted was just pure exclamation mark, so it worked. But anyway, I'll show this again. So 1, 2, 3, 4, 5, 6. Oh, it was because it's the same process. So I had to restart it. Yeah, because so we'll do 1, 2, 1, 1, 2, 3, 4, 5, 6. Okay, so we get lotto start. So after we initially put in the exclamation marks, we get lotto start. That's one new line, and then bad luck, which is another new line. So if we go back to our code right here, that was pretty funny though. What was it? So that's bad luck, and then what was the other thing? I forgot. Lotto start. So it prints out lotto start. So this receive line, it just prints out a line, and that line will be lotto start. So at this point, it prints out bad luck. And now in bad luck, if you saw carefully, if you saw carefully, the flag, it doesn't say the word bad. In our case, if it contained bad luck, that means it failed. So that's what I have right here. So if I go back to my code, if bad is not in the second part, which prints out bad luck, we could assume that we have the flag and it prints out the second part. So what's basically doing, it prints out the menu, we send in a value, it asks us to enter 6 bytes, then we give them the 6 bytes, prints out lotto star, then it prints out bad luck. Bad luck, it's either going to contain bad luck or the flag. And if bad luck is not the second part, so that means it contains the flag, it prints out the flag for us. But if that's not the case, it goes back to the menu option, sends out one, asks us for 6 bytes again, then we send the exact same 6 bytes, because eventually it's gonna happen where that like in our case beforehand, that the first value in that lotto, this lotto array, is gonna be an exclamation mark. That's basically what's going on with this code. And you saw right here, and it yeah, and it keeps on running instantly. So like, see, like if we press 1 and then 1 2 3 4 5 6, it asks us again, and we press 1 and then 1 2 3 4 5 6, and eventually it's gonna hit it. But in our case, A is not valid since it's not part of the 1 through 45. I just used this as a quick example. But that was about it for this challenge. On, and I guess if I didn't even run it, but like you guys saw the flag. But if I run this, yeah, eventually we'll get out Python. Eventually we get the flag. Sorry mom, I forgot to check duplicate numbers. So that was about it for this challenge for the most part. We'll just do auth. And I'm pretty sure, yeah, we're logging first. Oh, well, anyway, yeah, that was about it for this challenge for the most part. Um, yeah, and I guess one way that the developer could have saved this code is if we do cat solve. Oh no, cat lotto.c. One way you could have saved this code technically, but it probably wouldn't make sense if if both of these were the exact same value. If either if lotto at I and submit at I, or lotto at j is equal to lotto at j. That's one way the developer could have fixed this code. But then at that case, like, why have the second for loop? Yeah. Anyway, that was about it for this challenge. Hope you guys learned something new. I did, and see you on the next one. Peace.